Now we go straight to the next, and that's number 6. 6a. The set M, which has elements n such that 2n minus 3 is less than or equal to 37. Yeah, set M has element n such that 2n minus 3 is less than or equal to 37, where n is a counting number. That simply means n is a positive number. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Roman figure 1. Write down all the elements of M. Okay, let's do that. These are going to be the elements of M. N is such that 2n minus 3 is less than or equal to 37. So let's put n equals 1. If n is, let's test 1. If n is 1, that means 2 times 1 minus 3, and that's 2 minus 3, which is minus 1. Minus 1 is less than or equal to 37. Since the result satisfies the condition less than or equal to 37, that means 1 is one of the elements of the set M. So we test 2. If you put n equals 2, that means 2 times 2 minus 3, that's equal to 4 minus 3, 1, which is less than or equal to 37. That means 2 is also an element of the set M. We now test 3. 2 times 3 minus 3 is the same as 6 minus 3, which is 3. That's less than or equal to 37. That's actually lesser. That satisfies the condition less than or equal to 37. So that means 3 is also a member of the set M. We go to 4. 2 times 4 minus 3, that will be 8 minus 3, which is 5. And it satisfies the condition less than or equal to 37, which means 4 is also an element of the set M. We go to 5. 2 times 5 minus 3 is equal to, that's 10 minus 37, which satisfies the condition less than or equal to 37. That means 5 is also an element of the set M. We go to 6. Let me erase all of that. Now we go to 6. 2 times 6 minus 3 is equal to, that's 12 minus 3, which is 9, and it satisfies the condition less than or equal to 37. That means 6 is also an element of the set M. And then we go to 7. 2 times 7 minus 3 is equal to, that's 14 minus 3, 11, which satisfies the condition less than or equal to 37. That means 7 is also an element of the set M. We go to 8. 2 times 8 minus 3 is equal to, that's 16 minus 3, which is 13. And that also satisfies the condition less than or equal to 37. It must either be less than or equal to 37. That means it's either smaller than 37 or exactly 37. So since 8 satisfies that condition, that means 8 is also an element of the set M. If we go to 9, 2 times 9 minus 3 is equal to, that 18 minus 3, which is 15. That satisfies the condition less than or equal to 37. That means 9 is also an element of the set M. We go to 10. 2 times 10 minus 3 is equal to 20 minus 3 is 17. That also satisfies the condition less than or equal to 37. So that means 10 is also an element of M. And then to the next, which is, the next one is 11. Let's check that. 2 times 11 minus 3 is equal to, that's 22 minus 3, which is 19. And that also satisfies the condition less than or equal to 37. That means 11 is an element of M. We go to 12. 2 times 12 minus 3 is 24 minus 3, that's 21, which also satisfies the condition less than or equal to 37. So 12 is also an element of M. And the next one, let's check 13. 2 times 13 minus 3 is equal to 26 minus 3, 23. That also satisfies the condition less than or equal to 37. That means 13 is also an element of M. The next one is 14. 2 times 14 minus 3. 2 times 14 minus 3, that's equal to 28 minus 3, which is 25, and it satisfies the condition less than or equal to 37. So that means 14 is also an element. We go to 15. 2 times 15 minus 3 is equal to, that's 30 minus 3, 27, and that also satisfies the condition less than or equal to 37. So that means 15 is an element of the set M. We go to 16. 2 times 16 minus 3 is equal to, that's 32 minus 3, which is 29, and that also satisfies the condition less than or equal to 37. So 16 is also an element of M. We go to 17. 2 times 17 minus 3 is equal to 34 minus 3, and that's 31, which satisfies the condition less than or equal to 37. That means 17 is also an element of the set M. We go to 18. I think yeah, we're getting to the last one. 2 times 18 minus 3 is equal to, that's 36 minus 3, which is 33, and that also satisfies the condition less than or equal to 37. That means 18 is also an element of M. The next one is 19. 2 times 19 minus 3 is equal to 38 minus 3, which is 35, and that also satisfies the condition less than or equal to 37. So that means 19 is also an element of the set M. We go to 20. 2 times 20 minus 3 is equal to, that's 40 minus 3, 37, and this also satisfies the condition less than or equal to 37. So that means 20 is also an element of the set M. Now let's check a last one. Let me check 21. 2 times 21 minus 3 is equal to, 2 times 21 is 42 minus 3, that's 39, and this does not satisfy the condition less than or equal to 37. So we write it this way. That means it does not satisfy the condition less than or equal to 37. So that means the last element of the set M is 20. So the elements of the set M are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now let's see. That looked like a long one, but we needed to just go through the elements, go through obtaining the elements that way, so it will be easy, so we don't get confused. Now, so we can understand it easily. Now the next one is Roman figure 2. If a number is selected at random from M, that means from the set M, what is the probability that it is alpha? Roman figure 2 has two questions. Roman figure 2 alpha. What's the probability that it is alpha? Question alpha, a multiple of 3. Now the set M, let's see. So probability that any number chosen, let me just write that, probability of multiple of 3 will be equal to number of elements of the set M that are multiples of 3, and that's going to be 1, 2, that's 3 itself, 1, let me do this, that's the 3 itself, 6, that's 1, 2, 3, 4, 5, 6, yeah. So the number of elements of the set M that are multiples of 3 is 6 divided by the total number of elements of the set M, and that's 20. 6 over 20. So the probability of obtaining a multiple of 3 when a number is chosen at random, when a number is selected at random from M, is 3 over 10. 6 over 20 is the same as 3 over 10. Now we go to 2 beta. This is question beta. Now what's the probability that if a number is selected at random from the set M, it is a factor of 10. So let me just say P, probability that the number is a factor of 10. P factor of 10 equals, how many elements of the set M are factors of 10? Let's see that. Factors of 10, that's 10 itself. Factors of 10 means numbers that can divide 10 without any remainder. That's 2, 5, and the 10 itself. So those are just 3, they are just 3. So that will be 3 over total number of elements in the set M, which is 3 over 20. And that's it. Very, 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 very simply. I think I want to take a breather and then come back to 6B. Alright, thank you very much, and I'll catch you in the next.